Sensor networks, introduction and architectures. Wireless sensor network. What are sensors? A sensor is a device that responds and detects some type of input from both the physical or environmental conditions such as pressure, heat, light, etc. The output of the sensor is generally an electrical signal that is transmitted to a controller for further processing. All types of sensors can be basically classified into analog sensor and digital sensor, but there are few types of sensors such as temperature sensor, infrared sensor, ultrasonic sensor, pressure sensors, proximity sensor, and touch sensors that are frequently used in most of the electronic applications. Wireless sensor network. WSN is an infrastructure-less network that is deployed in a large number of wireless sensors in an ad hoc manner that is used to monitor the system physical or environmental condition. Given is an example of WSN. Here we see there's a user, internet, a base station connecting the sensor nodes along with the internet, and the sensing region contains the sensor nodes. A sink or a base station acts like an interference between user and the network. One can retrieve required information from the network by injecting queries and gathering results from the sink. Typically, a wireless sensor network contains hundreds of thousands of sensor nodes. The sensor nodes can communicate among themselves using radio signal. Base station in a wireless sensor system is connected through the internet to share data. WSN can be used for processing, analysis, storage, and mining of the data. Components of WSN. First is the sensors, then radio nodes, VLAN access point, evaluation software. Sensors in WSN are used to capture the environmental variables and which is used for data acquisition, that is acquiring of data. Sensor signals are converted into electrical signals. Radio nodes. It is used to receive the data produced by the sensor and sends it to the wireless LAN access point. It consists of a microcontroller, transceiver, external memory, and power source. Wireless LAN access point. It receives the data which is sent by the radio nodes wirelessly, generally through the internet. Evaluation software. The data received by the wireless LAN access point is processed by a software called as evaluation software for presenting the report to the users for further processing of data, which can be used for processing, analysis, storage, and mining of the data. Characteristics of wireless sensor network. Power consumption constraint for node using batteries or energy harvesting, chance to cope with node failure, that is resilience, mobility of nodes, heterogeneity of nodes, scalability to large scale of deployment, capability to withstand harsh environmental conditions, simplicity of use, cross-layer design. Advantages of WSN. Network setups can be carried out without fixed infrastructure, suitable for the non-reachable places such as over the sea, mountains, battlefield, surveillance, rural areas or deep forest, flexible if there is random situation when additional workstation is needed, implementation pricing is cheap, it avoids plenty of wiring, it might accommodate new devices at any time, it is flexible to undergo physical partition. Advantages of WSN. WSN is it not fully secure? Hackers hack the network easily. It is easy for a hacker to hack it. We couldn't control propagation of the waves. Works at short communication range. Consumes a lot of power. It has a short battery life. Sensor nodes need to be charged after a few times at intervals. Communication speed is very poor. On the other hand, Wired networks have good speed of communication, more complicated to configure compared to the wired network. Applications of WSN: Internet of Things, surveillance and monitoring for security, threat detection, environmental temperature, humidity and air pressure, noise level of the surrounding, medical applications such as patient monitoring, agriculture, landslide detection. Differences between cellular and ad hoc network. First, let's see ad hoc network. It has no fixed base station. It's very rapid development, highly dynamic network topologies, single and multi-hop communication, hostile environments, irregular connectivity. Ad hoc network automatically forms and conforms to change, whereas the cellular network has fixed pre-located cell sites and base station, slow in deployment, static backbone network topology, single hop, relatively favorable environment, stable connectivity, detailed planning before base station. Is the difference between ad hoc network and wireless sensor network. The features that are compared between the two are number of sensor nodes, deployment type, rate of failure, battery, redundancy, data rate, change in network topology. First, we'll see all the features with wireless sensor network. The number of sensor nodes are large in quantity. The deployment type is very much dense. Rate of failure is more. Battery need not be rechargeable because it's hard to recharge. Redundancy is high. Data rate is low. There's a frequent change in network topology. Next is the ad hoc network. Number of sensor nodes are medium in quantity. Scattered deployment type. Rate of failure is very rare. Battery is rechargeable. Low redundancy, high data rate, and rare change in network topology. These are the differences between ad hoc network and wireless sensor network. Challenges for wireless sensor networks. Major issues and challenges that affect the design performances of the wireless sensor network are energy efficiency, quality of service, security issue, deployment, node cost, limited bandwidth, scalability to large scale of deployment, fault tolerance, multi-hop communication, and finally design constraints. First is the energy efficiency. The first and often most important design challenge for WSN is energy efficiency. Power consumption can be allocated to three functional domains: sensing, communication, and data processing, each of which requires optimization. The sensor node lifetime typically exhibits a strong dependency on battery life. The constraint most often associated with sensor network design is that sensor nodes operate with limited energy budget. Typically, sensors are powered through the batteries, which must be either replaced or recharged when depleted. For non-rechargeable batteries, a sensor node should be able to operate until either its mission time has passed or the battery can be replaced. The length of the mission time depends on the type of application. Second design challenge is the quality of service QoS. Some real-time sensor applications are very time critical, which means the data should be delivered within a certain period of time from the moment it is sensed. Otherwise, the data will be unusable. So this must be QoS parameter for some application. Third is the security issue. Many wireless sensor networks collect sensitive information, especially for military application which carry sensitive data. The remote and unattended operation of sensor nodes increases the exposure to malicious intrusion and attacks. Further, wireless communication make it easy for an adversary to eavesdrop or sensor transmission. For example, one of the most challenging security threat is a denial of service DOS attack, which goals is to disrupt the correct operation of the sensor network. Fourth is the deployment. Node deployment is a fundamental issue to be solved in WSN. A proper node deployment scheme can reduce the complexity of problems. Deploying and managing a high number of nodes in a relatively bounded environment requires special techniques. Hundreds to thousands of sensors may be deployed in a sensor region. There are two deployment models at present: static deployment, dynamic deployment. The static deployment chooses the best location according to the optimization strategy, and the location of sensor node has no change in lifetime of WSN. The dynamic deployment throws the node randomly for optimization. Node cost. A sensor network consists of a large set of sensor nodes. It follows that the cost of individual node is critical to the overall financial metric of the sensor network. Clearly, the cost of each sensor node has to be kept low for the global metrics to be acceptable. Depending on the application of sensor network, large number sensors might be scattered randomly over an environmental such as weather monitoring. If the overall cost was appropriate for sensor networks, and it will be more acceptable and successful to user which need careful consideration. The sixth challenge is the limited bandwidth. Bandwidth limitation directly affects message exchanges among sensor, and synchronization is possible without message exchanges. Sensor networks often operate in a bandwidth and performance constrained multi-hop wireless communication medium. Presently, wireless communication is limited to a data rate in the order of 10 to 100 kbits per second. The seventh challenge is the scalability to large scale of deployment. In some applications, tens of thousands of sensors might be deployed together. At any time, numbers of nodes can be increased or decreased. A synchronization scheme should scale well with increasing number of nodes and a high density in the network. Eighth challenge is the fault tolerance. In a hostile environment, a sensor node may fail due to physical damage or lack of energy. If some nodes fail, the protocols that are working upon must accommodate these changes in the network. As an example, for routing or aggregation protocol, they must find suitable paths or aggregation point in case of these kinds of failure. The ninth challenge is the multi-hop communication. The need for multi-hop communication arises due to the increase in the size of wireless network. In such settings, sensors in one domain communicate with sensors in the another domain via an intermediate sensor that can relate to both domains. Communication can also occur as a sequence of hops through a chains of pairwise adjacent sensors. The last challenge is the design constraint. The primary goal of a wireless sensor design is to create smaller, cheaper, and more efficient devices. A variety of additional challenges can affect the design of sensor nodes and wireless sensor network. WSN have challenges on both software and hardware design models with restricted constraints.